Hello everyone, and last time I showed you how I implemented the backbone for my finance automated training with reinforcement learning. As you might see right now, I'm showing you the structure of my previous code project, what I did. And this time I decided that I'll add this AI stuff and we'll try to trade the AI algorithmic trading. And you'll see how huge profits it can make. So, but first, let me cover what I did, what I changed, and how I implemented this. So, first, I would like to show you what before I did and what we were missing. So, basically, we were missing this AI agent inference, memory, agent training, and some logs with TensorBoard. So, right now, I have another picture. I have here FinRock. And you might see that in this video, I added way more stuff than before, except live data feeder. So live data feeder will come in the last step when we'll try to go to the live market. Right now, we need a lot to cover before doing this. We need to make sure that our agent works fine, it can do profit, and it gives us a lot of metrics and statistics and etc. So we could track how our agent is trading. So you might see that new stuff appeared here. There's metrics and indicators that are not implemented yet, but I plan to do this in the next tutorial. And these indicators should appear along the state so we could normalize them together with our open, high, low, close prices, of course. So this is the structure that I already implemented in this tutorial, and I would like to walk through it to make you familiar with it because, well, if you were following my first and second tutorial, you must see how fast my project grows. And if you would like to understand everything, you need to take attention to every detail, because a few more tutorials later, you won't be able to understand what is where, of course. For me also, it's getting pretty hard and hard to understand what it is. So, okay, let's move on. So first, I would like to show you that what might changed in my Git. So this is my commit that I will push for changes. So you might see there's a lot of changes. And before I had this playing.py script that I don't have it right now. And this was only playing random sinusoid stuff that I pushed into experiments. And okay, let's zoom it a little bit for you. And now I have this, and this is simply a random game that we are playing. And that's it. So what appear here new is these metrics. And what are metrics? You probably should know, even if you're not programming or etc. But usually what we want to know when we are doing some trades or automated trading, what is, for example, our win rate, loss rate, what is our average profit or total balance, or even some max drop down, Sharpe rate, or etc. So for this purpose, I implemented the metric object that we are adding into our trading environment, and all these metrics will be automatically calculated, and later we'll easily can log these into TensorBoard. So we will know what agent what did. So I implemented this metric, and I implemented right now only two different metrics, different actions. So I'm interested when I'm training my agent, how many buy and sell actions my agent is doing. So, well, this is a pretty useful metric, I believe. And of course, I would like to know what's my account value, how it grows during the trading period, and while I train it further and further, how it changes, of course. And these two metrics help me to follow this stuff. Okay, let's see what else what I did. Okay, I did a render, a lot of changes in render. Let me show. So I slightly changed the default sizes of my screen width and height. I now added the render balance. So this means that I'll add a render to the render the balance of my account. Well, it's a little bit interesting more to follow the change of my balance even more in the testing, you'll see. And of course I added the pause because usually when it's rendering pretty fast and we can't follow it and to understand what is where. And so I added a pause button as a spacebar, and we press it, it pauses me the render, and I assume to it with again pressing the spacebar. Next, I defined the font. Also, before in the second tutorial, one of the viewer commented that it's pretty complicated to understand when we are doing buy or sell actions. And usually we were doing this on a close price, but usually we were drawing this on a next candle, so it was pretty complicated to understand. So right now I did slightly change it. So right now it draws us where we do a buy or sell on the same closed candle. So, and we print a price, of course, of my account value. And that's it. If you can take a deeper understanding into it if you're interested, but I'm not wasting a lot of time here. Okay, next, what I changed is my trading environment. So as I said, I added the reward function. No, not reward function, but metrics. And we are handling these metrics automatically. So I added the property metrics that returns these metrics, and of course I created metrics handler that always loops through our metrics and updates it. And of course, when we reset our environment, it resets these metrics, and we return these metrics together with our info dictionary. So later we could easily plot these into TensorBoard. And that's the main changes here. What else changed? Of course, version changed, and yeah, I think the most change is within the reinforcement learning part, because as you might see, I added this RockRL library. That's my library that I also working aside. And if I open GitHub, I should find it. I go to my projects, repositories, and RockRL. Yep. And I only have implemented the PPO algorithm for reinforcement learning because, well, I'm right now will try on PPO training. I won't try A2C, deep deterministic policy gradient, deep QN, or etc. Simply, I implemented PPO in TensorFlow for now. Later, I maybe move to Torch to test this out because others also love to test out Torch, and it has other advantages than disadvantages. And of course, it will be interesting to test if it trains more efficient or not. So this is my RockRL package. You can install it from pip. There is several examples how you can do this. I even trained the Bipedal Walker Hardcore on this, and it works pretty amazing. And yeah, I'm using this my own package that I'll update if I'll need. So there will be a huge compatibility with my FinRock package because, of course, I use my own reinforcement learning library. So let's move to the code again. I use TensorFlow and only because I am on Windows right now. And I use 2.10, and this RockRL package, at least for now, is dependent on TensorFlow probability. I noted that that's not the best thing that it has this dependency, and I will decide that I'll need to remove this dependency. So before next tutorial, I'll try to do so. If not, okay. So then we'll be able to move to higher TensorFlow versions because 2.10 is dependent on 0.18 version of TensorFlow probability. And well, A lot of people are developing on Ubuntu, me too, but usually I'm recording on Windows because it's more convenient for me. And RockRL package 004, and I'm using this simply. So let's go to my training, and I have here training PPO sinusoid. This is totally new code, and what I did here, I imported TensorFlow, keras, layers, models, and etc. And I import the same stuff from FinRock as in random sinusoid, except these metrics, they are new. Then I add mean average, memory, and PPO agent. If you're interested how to use this RockRL, you should move to my another GitHub, test the examples, check them out, how to train the discrete environment, continuous environment, and etc. And it will be way easier to you to implement this if you want. So next, I have the same random sinusoid data as in playing a random sinusoid game, except that I leave the last 1000 candles for the testing, and I use this only for training. So I create this data feeder as in my image data feeder, right? And I'm using everything except live data feeder and indicators. So I create this trading environment the same as before. I add these metrics. I use window size, initial balance, max scalar, and etc. That's only for me. And I get the action space from my environment, and I create these pretty simple models. This is a actor model and critic model, and right now this is a discrete environment, and I use the following activation as softmax for actor, and I'm not using any activation from critic. And I use for dense layers exponential linear union. I found this pretty efficient and works pretty okay. And then I create this agent, PPO agent, Proximal Policy Optimization. I feed it with actor and critic model. I define optimizer, my batch size, lambda. I define this key L coefficient. Well, you need to check my reinforcement learning tutorials if you would like to understand this. And I set the C2 as 001 and write the command PPL sinusoid, so I would understand what I'm training, and that's it. And of course, I should note that reinforcement learning is dependent on various a lot. These parameters are crucial. Usually, if it's not training, 90% default will be hyperparameters, and it's really hard to train, because of course reinforcement learning is not some kind of computer vision training or transformer. It requires a lot of episodes to play. For example, we train 1 mile, we play episode. We train, we play. We train, we play. And this playing usually takes more time than training. And well, here comes the disadvantage of reinforcement learning, but what we can do. Okay, then I create this memory. This is also from my previous, for my reinforcement learning tutorials. I create mean average. So this here, I'm tracking average score of my environment, and here is window size of 50. This means that I average, I simply average these 50 values, and I receive mean average reward, and simply I save the module according to it. So as usual, I will set reward, and here is the before what it was, the action of random or a hold, but it's not necessary totally. I think I can remove these, and not random. I use the actor, and we receive this action and probability, and we do the step to the environment, our action, etc. And then we save the results from our environment into the memory. And then we repeat this stuff, and we check whether our environment finished. This is the way I do this, is memory done. I check whether there is some truncated or finished environment, and if it finished, as you might see, I receive the history. By training the agent, I calculate the reward. If it's the best, I save the agent. But another is crucial stuff that I use is history, and I reduce learning rate if this value is larger than 0.45. This is KL divergence. And what it is actually, this shows us how huge how different our new trained agent weights are from the previous episode. And I noticed that if it's too high, well, it doesn't train too well. So I decided that it's a very nice option to reduce learning rate if it gets these spikes in weights, the huge change, I can say, and it reduces this learning here. Well, next I simply print it, log everything into TensorBoard from my metrics. As you may see, it's as simple as this. And then I simply reset memory, environment, and etc. And I repeat. And agent epochs is, well, when we train it for 10,000 epochs, I simply break it because I assume it would be trained on this at least data, on the sinusoid data, and we are good to go. So right now, I think I can show you how it trained. Well, I can run this for you to prove that it works and what it logs while it's training. So give it a few moments to load everything up for me. Yeah, I have 1080 Ti GPU. I believe it would be a great time to renew for me in this GPU, but well, I don't know. I don't have finance for this. So great, as you might see, it's training, and what we see, the epoch, reward, sum of reward, mean reward, and what we see is account value, history KL divergence. So this is the crucial stuff that we expect it to grow while it's training. But now, while I'm recording, it's training pretty slow and I can't do anything. And it has a huge dependency on what CPU I have, because better CPU I have, faster it would train. And of course, this environment is not parallelized for now, but I plan to do this in the future. And you might see our memory reward is increasing. Here we receive 2.54, and that's pretty amazing. And it keeps increasing. So I already trained an agent before, and I can show you how it worked. So I close this. I have these runs, copy relative path, TensorBoard, log directory, runs. Let's open these TensorBoard logs, and I will show you what I had there, of course, how we trained, and etc. And let's open my browser, TensorBoard. Okay. Scalars, and yeah, this is right now a new ones that I try, and you might see I trained it for 10,000 epochs. That's very nice. So actor loss, account value. So this is the first stuff that you should be interested. As you might see, my account value kept growing while I training, and here you might see that I'm receiving millions of dollars from at least 10,000, from 1,000. As here I had a value of 5, 7, and etc. thousands. Here I receive a millions only because it trained to do these trades. So what is my different actions? Well, in average, in one episode, it does 350 actions. So So this means something like 3 actions in 3 candlesticks. That's great. Let's move to entropy. That's also great. It dropped, increased, and kept dropping while it was training. This is also pretty great. It kept decreasing because I was reducing the learning rate on each spike. And here I started training with 1e minus 5, and here it finished around 1e minus 6. That's great. And this is what was the goal here. As you might see, the rewards. Well, these rewards kept increasing, and until right now, my agent learned many good things. Let's look at the loss. It's pretty hard to understand. Yeah, but these are the crucial stuff here, that my rewards kept increasing. This means my agent was learned to do stuff. And here, it kept, this sigma kept decreasing. And what is sigma? Sigma represents the randomness in environment. How confident our agent is with his actions. So it started with high, and simply it kept decreasing all these training steps. So great, but I believe you would like to see how my agent performs in actually that I trained. So let's do this. I'll show you. So here I have this testing, and I have here a trained agent. I believe this one. Yep. And let's run this. It will give us the render, and you will see how it works. Let's wait for it to load. Of course, it should load TensorBoard model. Yeah, here it is, as you might see. Why it is so huge? Okay, let's make it full screen. And it's training, as you may see. This is my trained agent, and you might see that here account value was 1,800, and here it bought on this close, and here it sold on this close. And here again, here it bought, here it closed. Well, something wrong with the render here, but I'll fix it, don't worry. And the value kept increasing along, and this is my trained agent. Well, one disadvantage is that this is sinusoid data, but who cares? My goal was to make sure that at least we can train something. So for this purpose, I had to gather some data that we wouldn't be able to predict what will be later, and do some kind of trades on these data. And you can see the results, at least. Here, I already have $500,000 from $1,000. Can you imagine if this would be a real market? I can't. And I'm really surprised and amazed of my own results, what I was able to do, because I made sure that it works. And as you may see, it kept training, and what results we can get is already have 3 millions, 5 millions, and we kept going to 6 millions. Okay, we had lost some here, 8 millions, 10 millions, 12 millions, 14 millions, 16 millions, 21 million, 30 millions, 40 millions, 46 millions, 47, 56. Oh shit. Did you saw it? That's amazing. And this was my goal. And right now I'll be able to move further to this, my own, of course, platform, to this project. I need to add a lot of metrics to it, so we would able to track the sharp ureta and many others, drawdown, etc. Of course, I would need to add the continuous environment, so it wouldn't risk all the balance at once. So there is a lot of stuff that I should continue doing, and this, maybe after a few more tutorials, I'll try to do this with a live market data. But at least for now, That's a great result for me, and I'm really excited about that. And you should be also to be excited about that. So I hope this tutorial was useful for you and will be able to do something great with it. And you might see the results are great. And if you like this and you watch until then, don't hesitate to smash the like button, subscribe to my channel, and share. And if you have any suggestions, you can comment. And if you find any bugs, go to my GitHub page and create an issue there. I'll try to solve it, because you might see that this project starts getting some great love, I believe. So that's it for this tutorial, and we'll see you next time. Thank you for watching, and goodbye.